Okay, hello all you crazy people out there. My name is Michael, I like wizards and dragons and making games, and let's make some tower defense games. Alright, Bombardier. This is, let's see, what did we do last time? I don't remember, it's been a couple days since I've recorded one of these. There is now a bunch of quality of life additions that I have made since the last time I did this. For example, the user interface especially, you now see how much it costs to build a tower. You see how much it costs to upgrade a tower, to sell a tower, that kind of thing. There are some tower stats, which is fun to have. Those two leaked through. That's unfortunate. There's still a lot to do, especially in terms of polish, but we'll get there when we get there. Today it is going to be we're going to be talking about optimizing this thing. So this game doesn't run terribly. At least on my computer. You can see it's running at 60 frames per second. It's getting about a 200 or so FPS underscore real. And that's okay. It's not a hugely complicated game. There's not a ton of stuff going on in it, but there's still certainly a lot that we could do. I have, in the last couple of weeks, been making a mini-series on optimizing 3D games in GameMaker. And I should probably upgrade this guy. So that hopefully... Nope, those two are going to leak through anyway. I have made a bit of a mini-series recently on optimizing 3D games in GameMaker, and a number of those little optimization strategies are going to be coming in useful here. Let's talk about some of them. Specifically, one big one is going to be coming in useful here, but let's not get ahead of ourselves. So, first let me run this on the Raspberry Pi, because that is something that I like to do, and... Is my Raspberry Pi even turned on? The light's on. I think it's turned on. We can use that as a bit of a more intensive performance benchmark. I'm not sure if I'll be able to make this game run at a steady 60 frames per second on the Raspberry Pi, just because it's a Raspberry Pi and I'm not going to do... GML is an inherently slower language. I may mess with the Yo-Yo compiler. I probably will not mess with the Yo-Yo compiler. But we'd like to see it playable on it anyway. Certainly I'm hoping for 30 frames per second. And if the capture program can ever open. Okay, the Raspberry Pi is on. Let me go and run this game on it. I'm fully expecting to see like 2 or 3 frames per second maximum on this thing because again, this has very little optimization and the Raspberry Pi is a considerably weaker piece of hardware than my computer. So we shall see. It's going to take a moment to boot up. And honestly, the load time itself is something that could be optimized greatly. I am getting 10 frames per second on this thing, which is actually quite a lot more than I was really expecting to see. We're seeing a couple other minor differences. One is that texture interpolation on Linux by default is turned on. I should probably turn that off just to make it consistent with Windows. If I were to attempt to play the game, I'm sure... Am I seriously now pushing 20 frames per second? That's impressive. Let me send in a wave and see what happens. Okay. I think in a tower defense game, we are seeing that delta timing is actually probably not a desired effect. And I might get into that later. There's a couple problems that delta timing can bring in when your game is running at like these kinds of frame rates, but that's a discussion for another day. Anyway, that's what we've got to work with right now. So let's see, let me switch the target back to Windows. Again, I could use the Yo-Yo compiler for this, and that probably will speed up the game a little bit, but I do not want to do that. I have not made any videos yet on the Yo-Yo compiler. Hey. For those who don't know, that is converting your GML into C++, and don't get too excited about that because it's not optimal C++. There still is a lot of extra stuff that GameMaker does to make it work, so it's not as fast as native C++, but it can afford a nice performance boost. For certain situations. In any case, I won't be talking about that right now. Probably by the time I build the final executable, I'll talk about that a little bit, but not right now. Anyway, so that's what I have to beat. That's the frame rate that I have to beat right now. I could fuse all the vertex buffers into a single vertex buffer when the game loads, which is going to be like down and load map, this function here. But instead, I think I am going to do that when you go into the editor and hit a key on the keyboard, because as you're designing levels, you're probably going to want to be able to like work with all of the environment entities, and then only fuse them together when you're finished making the level. So F1 to save, F2 to view and hide path nodes. I can say perhaps F3 to fuse everything together. And let's put that on its new line. F3 to fuse all of the environment entities together. And that's fine. In the game's update, there should be a part of the update function that's for like editor stuff. And this is going to be editor path mode. Don't care about that. Oh no, that's collapsed. I guess I'll just put it at the beginning here because I don't know where in my code I want to put this code. F3, and then we can just show message so that we know that code actually runs. And this is going to be I'll make the fusing code F3. Yeah. Okay, so that's going to show a message. I'm going to make the fusing code a method of its own because, like, you know, DRY, don't repeat yourself. First, let me make a commit, getting ready to fuse all the stuff together. Did I straighten out the business with it looks like I did. Okay, so I was gonna ask if I remembered to straighten out the business with the one episode getting split into 2 videos and having to like redo all the tags and stuff. And it looks like I did, so that's something I don't have to worry about. We can create ourselves a method. And I'm just gonna call that fuse map entities. I really like the word fuse in lieu of nothing. I just really like the word fuse. And then we can call that method when you hit the F3 key. Okay, so this is going to run a little function here, and it's going to let's see, this is where all the other stuff of interest is going to happen. I could borrow the code from the 3D optimization video that I wrote, but I don't really want to do that. I want to write this from scratch because honestly, it'll probably take the same amount of time to do that as it will take to just honestly, it'll probably take about the same amount of time to write this code from scratch as it will to like open that other project, find the code that I'm looking for, copy, paste it in here, and make sure it works with all the same objects and everything. So let's start by for is it an array or a DS list? I think it's a DS list. Hang on, let me collapse the update method again because I'm done with that. Let me collapse save map because I'm done with that. Okay, it's the DS list all environment entities is what I'm looking for. Okay, so it's a DS list size all environment entities I++. I keep hitting the page up and page down buttons when I don't mean to. No point in typing that over and over again. And environment entities are going to have a couple properties. One of them is going to be, I believe, the 3D model. Okay, I was looking at the wrong constructor. Yes, indeed, it is a environment entity.model, and that is the vertex buffer. We can also get that vertex buffer. That's just going to be entity.model, really. We should be able to buffer create from vertex buffer. I don't believe these are frozen. The type can be buffer fixed is fine. The alignment can be 1 is fine. And what we've got here is a pretty bog standard 3D position, 3D normal, 2D text coordinate, and 32 bits of color vertex format. And let's see, we can then iterate over the vertex buffer. Buffer get size. j plus equals 36 bytes. That's just the size of the vertex format. You can add them up. Again, refer back to the optimization video. And we can say var xx is going to equal buffer peak. The offset is going to be j plus 0. I'm going to space this out a little bit. The type is going to be buffer float 32. Same for y, same for z. Normal x, normal y, normal z. Edit the offsets, 4, 8, 12, 16, 20. X text is going to be, I'm going to try and make all these two letters long. X text is going to be 24, Y text is going to be 28, and color is going to be 32. And that contains both color and alpha. Next, I need to actually do something with these to put these into a vertex buffer. I'm going to start in the beginning of the fuse map entities function and say var vbuff equals vertex create buffer. Vertex begin, the vbuffer and the vertex format. And then at the end, vertex end and vertex freeze. As a sort of completing those. Actually, I won't vertex freeze right now. I'll vertex freeze later once this is actually running, because I will need the ability to actually get the original buffer back from this so that it can be saved to a file. Next, we need to transform these vertices. I am going to matrix build based on the position, rotation, and scale of the entity. That can be matrix build. You really should combine these matrices and stages, but it's going to end up with the result that I want. So X is going to be entity position.x, position.y, position.z. Let's put these on their own lines. It is rotation, right? I did call it rotation. Okay. I wasn't sure if it was rotation or just rot, because sometimes I abbreviate rotation as that. Like that. Okay. That's going to be the matrix that we're transforming each and every one of these vertices by. I also am going to need another one that just doesn't use the position, and that's going to be for the benefit of the normals, I think. Yeah. So we can have our entity matrix normals, because we don't have a version of matrix transform vertex that uses a homogeneous coordinate of 0, unfortunately. New position is going to be matrix transform vertex. That is going to be entity matrix and x, y, z, x, y, and z. New normal is going to be matrix transform vertex, but with entity matrix normals and the normals. I don't believe this game has non-uniform scaling in it anywhere, because that would look fairly weird. I believe the x, y, and z scales are all uniform. They're all the same values for everything. But just in case, we can normalize this vector, this array of 3 values. This is going to be a array of 3 values, by the way, not a vector 3 like I've defined elsewhere. We can have the the point distance 3D function to get the 3D magnitude of the new normal value, and then normalize it by dividing each of the components by the magnitude. So that's going to produce the results that we want. So we can add these to the vertex buffer. Vertex position. This can be vbuff the xyz. Nope, it's got to not be xyz. It's got to be new. position, X, Y, Z, the transformed versions. Vertex normal, new normal, like so, vertex, text, chord. Those are just going to stay the same. Those are just going to be the X text and Y text because texture coordinates don't get transformed like this. Why is this showing a warning? Expected 3 got 4. Oh, this needs to be vertex position 3D. And lastly, vertex color. I'm going to cheat a little bit. I'm not going to go the long way around calculating and separating the color and normals and alpha transparency, whatever, for this color value. Color is going to be the 32-bit color, the lower 24 bits of that 32-bit color, and alpha is going to be the upper 24 bits, the upper 8 bits of that color value divided by 255, normalized between 0 and 1. And that is going to be a vertex. Alright, this should be all the math we need. The rest of this video is just going to be a matter of making it work nicely in our game and hopefully not having to do this too often. Let's see. So next, and that should be CC, by the way, because I made all of these vertex properties, all these vertex attributes, a 2-letter acronym. Next, I am going to need a way to, let's say, remove the actual entities from the list. And oh god, can I close the update method? Seriously starting to question my choices of putting all the main game code in the same file. All environment entities, I can dot clear that, at least for now, or ds-list clear that. It would be dot clear if this was a truly object-oriented language, which it is not. Like this. Nope. That's the correct one. C#, which is my generally favorite programming language, would be like list.clear instead of ds-list clear, and then you pass in the list as an argument, for those who don't know. Anyway, what this should do is this should create the vertex buffer in memory, but it's not going to do anything with it afterwards. I also need to do this at the end. Otherwise, we'll have a bit of a list synchronization error. Modifying a list at the same time as reading and writing from it. And this is going to make everything disappear because the vertex buffer isn't actually used for anything. It's just sitting there in memory. And let's see. I can go into edit mode. I can hit F3, and we have a buffer create from vertex buffer argument 1 unable to convert to integer. Okay, is that like, do we have a... Is that not just a vertex buffer? What is model? If I go into render, oh, it's model.vbuff, so model is a struct containing some information about the vertex buffer, and not the vertex buffer itself. That's fine. Okay. I should have looked at my code to see what it was doing before doing this, because it has been a little while since I've done something like this. F3. That's going to actually not make everything disappear. I'm guessing if I were to look at Task Manager, the game's memory just jumped a little bit. This is also something you could look at in the debugger, and it might give you a slightly more helpful view, but if I hit F3, my memory usage isn't actually going up. So it looks like, what is happening here? Do the models for each object have like a name? Okay, long story short, they do. So I can kick things off, debugging show debug message entity.model.name. And this is going to at least tell me if everything is indeed being fused or not. I would think it would be. I don't see any reason why All right, yeah, it is indeed fusing everything together, or at least it is iterating over every environment entity. I don't know what it is doing or not doing other than that. You know what I also kind of do need to do though, because this would be a memory leak, is I need to buffer delete this. Normally I would do that when I finish, but I forgot this time. Buffer delete raw buffer, and can I show message vertex get size, vertex get number, so that we can see how many vertices are being added to the vertex buffer. There's something else that may be happening, and that is that I believe all environment entities is also stored in the all entities list itself. All right, that is 169,026 vertices in this vertex buffer. Is that many? Didn't expect that many. If I divide that by about 400, because there are about 400 entities in the world, what was it, 160,000 divided by 400? That's about 400 vertices per thing. That seems a little high. Maybe there could be more vertices, there could be more objects in the world than I thought, or something else could be wrong. We'll find out either way. Anyway, God, I really should have looked at my code before I did this. Okay, so all entities.render is where that lives. I can remove some stuff. I can remove each of the entities from the environment entities, the like all entities master list. DS list delete. This is not the most optimal code, but this is only going to happen when I press a button in the editor, so it's not like a huge deal to me. So we can find each of the environment entities location in the master entities list, and then we can just delete it from there. Again, this is not the most efficient operation. This is going to have an upper bound of big O of n squared, but it'll do for now. You know, it might be faster if I iterate over the list backwards, but DS list find value argument 2 unable to convert to integer, result is not a number. Oh, is this going to return like -1? Or something, or undefined rather, if it doesn't find it. It should be -1. Oh no, it's DSList find index that I want. Okay, DSList find value would literally just be looking up an index in the list, which is not what I want. I want to find the index of a thing in the list. All right, this is going to be what, attempt number 4, and that did indeed freeze the game a little bit. Only now my browser's opening. All right. Chrome, I don't want... No. Yes, you can open the GameMaker Studio 2 manual. I don't think I need it anymore. All right, and that did cause an error when I hit a key on the keyboard. That's fine. Let's not worry about that right now. Let's make a commit. I will make it reappear later. I can say all the stuff is now fused together. I thinks. No, let us not have any spelling errors in my commit messages. Thank you very much. The next thing that we got to do is actually use a vbuffer for something, and this is getting into the territory of, like, I should create a map object, and the maps should own the data that belongs to each map, so that when you like select a level, you can load into different maps and that sort of thing, and it's not all super entangled with the rest of the game. But I can say all fused, like, stuff is going to equal, I'm going to call it undefined for now. In the end of the loop, I will just set I will just set all fused environment stuff to that vertex buffer. And we can draw that instead. Where is render? I keep opening the update method. I think that happens automatically when like I type code and IntelliSense takes a minute to, the syntax checker rather takes a minute to catch up, and like it suddenly doesn't know what any of my code is, so it just expands everything. It's rather annoying, but regardless, save, load, render, DS list clear, semi-transparent stuff, set the shaders, draw the ground vertex buffer. After we draw the ground vertex buffer, we can vertex submit all fused environment stuff. The primitive type, PR triangle list. I'm going to say -1 for the texture because all this stuff is just vertex colors anyway. If you really wanted to, you could build the vertex format to not include texture information, but it's not gonna save that much time or space by doing that. Like it'll decrease the amount of it'll decrease the amount of memory that the vertex buffer takes up somewhat. 8 bytes per vertex. It'll slightly decrease the amount of memory bandwidth you need to submit the vertex buffer, but other than that, I don't feel like wrangling different vertex formats. Anyway, this value has the potential to be undefined. So I'm going to go and check to see that that value is not undefined first before doing anything with it. And then, if I run the game now, we should now have all the stuff appearing again once everything is fused. And it just won't be editable, it won't be anything like that. So, edit mode, F3, and we no longer have anything. I can spawn my own, but nothing's happening. Alright, what did I exactly do to induce the error last time? I hit A key on the keyboard. I don't know what key on the keyboard I hit. It's unfortunate. The path nodes are all still there. Those aren't like part of the terrain or anything. So why is this being undefined? We'll start by our good old friend showed a bug message. And it should be either a number, which will indicate the presence of a vertex buffer, or it'll be undefined like it is right now, which will indicate the presence of nothing. So that is a vertex buffer. There should be a vertex buffer being drawn. Is everything ending up in the wrong place? Am I forgetting something crucial? Do I need to... Is the transform matrix like somewhere off in the middle of nowhere, and do I need to reset the identity matrix after this? That wasn't it. Oh, the matrix is the identity matrix. It's reset after the skybox is being drawn. Okay, this is where we have to go and debug my code. Okay, let's do everybody's favorite task and just look at the contents of this vertex buffer byte by byte. I can show debug message new position. This is going to make sure that each of the positions are more or less in the correct place in the world. I am also not going to iterate over the entire buffer, like every buffer. Every object in the world. I am just going to look at like the first 10 or so, maybe even like the first 5, and we'll just examine the positions to make sure they're in the correct place. Let's look at this, and this is gonna, when I do this, it's gonna spit out a bunch of just random assorted position values, and it didn't delete, like, a lot of stuff, did it? I think it just deleted a couple things off in that corner. Or something. Something like that. Anyway, let's look at these. Boy, these Kenny models really do have a lot of vertices in them, don't they? These should all be visible in the world. These should all be, like, 182, 81, 43. That's a position that's somewhere 182, 80, 143. It should be like here, where my mouse cursor is. That should be visible. Why it is not visible, I do not know. Is there some other draw setting that's not correct? There is another possibility, which is somewhat hilarious, and that is that, like, the vertices are all there, but they're all transparent. I don't think that's what it is, but let's just see. Did I mess up the transparency? That would be funny. I did disable the floor, by the way. Oh no, okay. That actually was it. So, for some reason, I'm reading out a 0 byte when it comes to color. Why am I reading out 0 byte in color? Oh, that's buffer F32. That should be buffer U32. Okay. That took kind of embarrassingly long to figure out. But when I did that, indeed, the entire world was C_black. Let me uncomment the ground. I mostly commented that out to see if like everything was suddenly underneath the ground or something weird like that, but no. It's just a matter of... Shut up, phone. It's just a matter of the colors being C_black and fully transparent. So now we have the world. If I were to... Oh, I'm spawning watermelons. If I were to go back into play mode, nothing would change. I still would not be able to... oh, I guess I can build. Okay, I still have your collision. I don't have your collision. I'm gonna have to do something with your collision. Alright. In any case, let me commit this change. We are now drawing the... Draw the... fused... environment stuff. And... out of curiosity, let's run this on the Raspberry Pi and see what happens. Just because I'd like to get a look at that. I am not going to expect to see too much of an improvement from this because, like I said in the mesh combining 3D optimization video, the Raspberry Pi's GPU is the bottleneck of the system, quite more than a CPU, and we still are ultimately trying to draw more triangles on the screen than the thing is really comfortable with. Okay, here on the Raspberry Pi, 20-something frames per second, very inconsistently. Let me go into edit mode. Let me hit F3. This is going to take a good couple seconds to run because this is, again, considerably weaker. The FPS real has gone up a little bit, but the frame rate that we're actually seeing, again, has not changed dramatically on the Raspberry Pi. Alright, so I should be able to, as before, like, place towers inside the environment because there's now nothing there telling us that we can't. Alright. So far, everything is working as expected. Or not working as expected, as the case may be. Let me come back over to my desktop computer. Let me move the mouse for the Raspberry Pi off my desktop so I don't accidentally try and use it. That would be awkward. And now we can move on to other things. So there are other optimizations that I do want to do for this game. There are quite a few. Some of the other things in that I talked about in the 3D optimization videos. There are some other things that I have yet to actually talk about as of my recording this, but probably will by the time the video goes up. There are some shader things that can be done to speed things up so that the Raspberry Pi has less work to do, but all that can wait. For now, I am going to edit... Actually, no, wait. What happens when... For collision. I do want to get collision squared away. I want to get collision squared away and then save the vertex buffer to a file so that it can be loaded fast without having to like wait for anything to process. What happens when you try to build a tower? Get collision free. Is collision free, I should say. So this is looking at the collision grid. Okay. And when is the collision grid edited? It shouldn't... Like... I don't think I'm doing anything to the collision grid. I'm not, like, officially removing anything from the world when I do this. Let's see. Yeah, add collision here. And I still do not... Oh, I know why I'm not... I think... Yeah, I was questioning in the last video why I did not just dsgrid set region for this, and that is because I am using the max of the existing value and the collision filled flag. Okay. Let's see. There is a is there a remove from world method? Because there probably shouldn't be. Or is there like a refreshing collision data? Oh, when you go into when you exit the editor, it resets the collision data. Okay, I understand now. That makes a lot of sense, actually. Because that is easier than trying to update the collision information on the fly every time you make a change. Okay, I'm okay with that. However, we still need to preserve some. We still need to preserve the entity collision information, and there's a boy. All right, what I'm going to do is I'm going to create myself a secondary DS grid. All right, let's create ourselves a secondary DS grid, and this can be. Where is like all collision or whatever? Collision? No. All right, collision grid. Okay, so here it is. Collision grid equals DS grid create. I can create myself another one for the fused collision data. DS grid resize. When I resize the main collision grid, I can also resize the fused collision grid, and boy, I don't know if I like. I suddenly don't know if I like add to map or not. All right, I have a really bad solution for this. This is where you get to see an example of it's horrible and you should never do it, but it works, so I'm gonna do it anyway in action. And that is going to be where is entity add to map. So environment entity add to map, environment entity add collision is what I'm just gonna call on each of the entities. All right, so all this does is it sets the values in the collision grid. This is gonna work, and I'm gonna hate it, but it's gonna work, so I'm not gonna complain. DS grid clear all collision grid fused. The value can be collision, I believe collision free, grid collision free. And then I am going to substitute in like I'm going to replace collision grid temporarily with the fused collision grid, and then I'm going to tell the entities that we're fusing to re-add the collision to the dummy grid, which is actually the fused collision grid. And then at the end of all of this, is the actual collision grid? Yeah, there we go. At the end of all this, we're just going to replace that. And we basically tricked the game into thinking that we're supposed to add to the fused collision grid instead of the one that we normally deal with. All right, that's I hate my life, but it's gonna work, so I don't hate it that much. Next, I need collision free, so that when you actually try to place a tower, which I believe is this line right here. You're going to call collision free. Yeah, that's in spawn tower. You're going to call collision free. That and also the can build piece of code down here when you're ready to spawn a tower. But we're going to make a slight adjustment to collision free so that it looks at not only the main collision grid, but also the fused collision grid. And I'm just gonna call it state so that we don't have variable names conflicting. And then the value that we're going to return is going to be if either of these values is true. Now, all right, there are some concerns that I have, but I will address those and I will code around them later, or code through them or whatever later. But for now, this should do. I don't see any reasons why this shouldn't. The whole point of collision-free, that method, is so that we can check to see if you're allowed to build somewhere and only have to do a single function call to do it. And I think this is encapsulating the principle of encapsulating. It is using the principle of don't repeat yourself fairly effectively. So
hey,
this is doing something similar, but I won't ever have to actually change this function, the collision is path function, because the path nodes will not ever show up on the fused collision grid for that little bit of collision information. So that's probably fine for now. Let me run the game and okay, yes, I am running this in Windows again and not the Raspberry Pi. I will run the game and I will see if I can actually get collision with the things that are fused together. So like right now, oh no. I can build right there. Why are we building right there? That was not the case the last time I did this, I don't think. Oh, you know what? Okay, so this is... Okay, that should be an and, not an or, because this is checking to see if the space is free. I thought it was checking to see if the space was occupied. So if you want to check if the space is occupied, you would use an and. You would use an or, because if one or the other of these values is true, then you would determine that the cell is occupied. But if you're going to do the opposite, if you're going to check to see if they're free, you want them both to be free. If you want the value as a whole to be determined to be free. And indeed, I cannot build here now. I can build there though. I don't know why. That's awfully close. Why am I allowed to build there? Okay, it looks like I'm allowed to build in the flowers and not like... I guess I'll just plop you down there. I'm allowed to build in the flowers, not in the trees. Anyway, if I were to fuse this now, that's going to take a second. We are now having much more FPS real. We still see everything. And can I build in the middle of the rocks? I cannot. I can build in the flowers, though. Okay. That's good. Next is going to be the matter of saving and loading this from a file. So we have two things that we need to save and load. One of those things is going to be the vertex buffer itself. The other one of those things is going to be its collision data, because we will not be retrieving the collision data from the vertex buffer. I am not going to attempt to do that, to build a collision mesh based on the vertex buffer or anything. That's going to be a nightmare. Well, I guess it wouldn't be a collision mesh. It would be more like some other hierarchy. But now when it comes to saving a map, we need to save a couple more things. And I gave it the .bug file extension. That's cool. One of those things can just be the vertex buffer. I can say var fused buffer or something like that. It's going to be buffer create from vertex buffer. That's going to be all fused environment stuff. I really should give that a shorter name. Type, again, buffer fix, alignment is going to be 1. Buffer delete when you're finished, and then buffer save. The buffer can be the fused buffer, and the file name is going to be, I'm just going to go with like the other file name. I'm going to save this to a separate file, but we're going to go with file name plus like dot fused or something like that. And that's going to save the vertex buffer to a different file separately, so that we're going to have the map itself, which is basically just JSON, and then we're going to have the raw vertex data. The map itself, if you were to open that up in a text editor, you would just see JSON, you would just see text. Whereas the vertex buffer, if you were to open that up in a text editor, you would see gibberish because that is binary vertex data. I will have to do one thing though, and that is going to be going onto Windows and, or is it disable file system sandbox? Because ordinarily when you save and load files in GameMaker, it has to be either part of the included files itself, so something in the data files folder that you supply when you ship the game, or it has to be something in the local storage for the game, which is on Windows the app data folder, and on Linux I forget where it goes on Linux. Or it has to be a file that you specify with get open file name or get save file name. And if you try to just write an arbitrary file, such as some other file with a new extension appended, you know what I can do that would actually make more sense and be less stupid would be file name change extension from whatever it is currently to just .fused. And then we won't have compound file extensions because those can get weird. I'll do that instead. Anyway, this will now be allowed, just saving or loading an arbitrary file. So, I am going to... Actually, you know what? There's one more thing, and that is, I completely forgot this. I need to save the fused collision grid. And I'm going to just ds grid write. For those who don't know, all of the built-in GameMaker data structures can do this. You can stringify them. You can encode and decode GameMaker data structures to a string. They won't be JSON, they won't be anything recognizable, they'll just be a base 16 encoding. I don't know why they chose base 16, but when you read or write a data structure, such as one of these DS grids containing a bunch of values storing collision states, it'll just serialize and deserialize as base 16. Once I'm done saving this, I will open up the file in Notepad++ and show you what it looks like. But anyway, that is how we are going to store and retrieve the fused collision information. This video is going on long. This is already an hour of recording, and there's probably going to be about 5 or 10 minutes of like bug hunting that I'll just cut out. But let's save. F1 to save. I'm going to save a test file. If I can get the file explorer, please. Why are we taking so long to open up the file explorer? Game can't have crashed yet. Okay, there we go. Windows was just taking its own sweet time. I'm gonna call that test.bug. And we'll just see that it works first. Okay, the game didn't crash on save, which is good. I will open up the data files folder. This isn't something I'm really going to worry about making work on the Raspberry Pi or anything like that, because I don't want to deal with all the possible errors that may be introduced by having the debug mode, the debug editor available on the Raspberry Pi. It's just an observation. Windows Explorer is really, really taking its time today. This didn't save. Did I save to the wrong location? Where did I save to? Okay, where did I save to? That did save, didn't it? The last modified date on this is October, so it looks like it either didn't save or it saved to some other location. Oh, this saved to my other project that I'm working out of. Okay. That's not where that's supposed to be. Hang on, let me go and retrieve that. This is Duck Game, by the way. Anyway, data files test.bug and test.fused. We can put those in here instead, which is where I want them. There is a lot more. Okay, I know why that is. I was gonna say the test.bug probably should have been smaller after that, because it's like removing a lot of information about entities and stuff, but it's actually, it contains a grid, an entire grid of, nope, don't want Microsoft Excel to open because I accidentally clicked on the controller database. This is most of this file is now just a really long ass, like, base 16 string, which contains collision information. And I could encode this as base 64 to save some space. I could compress this to save some space. That'll make it take a long time to load, though. If I, boy, my entire computer is taking a long time to just open literally anything right now. I think it's about time that I turn it off and let it cool down for a few days. If I were to go to a JSON beautifier, just online, and if I were to format it nicely, we are going to have a whole big old list of entities, most of which I believe are path nodes, and we are also going to have down at the bottom this big old base 16 string. I kind of wish GameMaker's DS grid read and write worked in base 64 to begin with, because that would just be faster for all involved. But this is what the collision information is stored as. All right. I could store this as binary data, but you know what? I don't want to spend even more time. That's the wrong project. I don't want to spend even more time trying to make this work than I already have. So let's just mark this as a commit. Let's save the fused terrain data. And when we load, we can look for some information, and that can be load JSON.nodes.entities. We can first extract the collision information, and that's going to be .fused collision. So I can say to undo the process of writing that dsgrid read load JSON.fused collision, and that's actually the string that we're reading. We also need to pass by reference the grid that we're going to feed that data into, because dsgrid read does not return a new data structure. It only modifies an existing one. Okay, and then of course there's the matter of the fused version. So buffer load, what is it? File name? Yeah, file name dot. I should change the extension again. File name change extension from whatever it is now to .fused. We can go in reverse. We can say buffer. Hang on, wait. We can say don't open the start page. We can say all fused environment stuff is going to equal vertex create buffer from buffer. That's going to be the buffer that we're sourcing from, and the format is just going to be format buffer delete fused buffer. And I think that's it. Not going to vertex freeze this yet. That'll probably be the last thing that I do in this video. Or I might just do that in the next one, because again, this is running on long. I should be able to if this isn't going to do anything, because I'm not actually loading tests.bug. Where do we load the map? UI text, UI button. Where's the one object? Where did I put this? Help. Alright, this is embarrassing. Oh, I literally called it backbone, which is extraordinarily, like, not helpful. Let me, let's see, reset these filters. That can at least go in the root folder of core stuff. Because it is semi-important, and it is important that I'm able to find it quickly. Load map, maps, / map.bug. Let's run test.bug instead. Alright, so I don't know if that actually loaded any faster. It looked like it took a moment to load regardless. But I can place down a pebble shooter. All the stuff is here. You see that we are running at a much more steady 600 to 700 FPS underscore real. Although again, shifting the responsibility from my CPU to the GPU, so that may not be super helpful. Or it may be, depending. And there is still collision, which is what I was worried about getting, and I had to think about how I wanted to do that for a moment. All right. Now, regardless, I'm going to keep around the old map.bug, just in case I want to go back to it later. I will also wrap a little bit of a if file exists around this code, just in case I want to load like the original map.test and there is no such vertex buffer file. How big is it, by the way? It is 6 megabytes, just for all that. Okay, we'll be working on cutting that down because not all of those triangles actually need to be there. Believe it or not, we'll be working on cutting that down, and that should help performance more than we already have. But load the fused maps from files. Okay, I'm curious how long this is going to take to load on the Raspberry Pi. So let me just go back to that. That actually arguably took even longer to load than it did before. Okay, so I will optimize this further later on. Anyway, that is where I'm going to leave this for today. All right, this is exciting stuff. Oh no, wait, you know what? I did say I was going to do one more thing, and that was going to be the vertex freeze, which should help additionally. So the matter of freezing the vertex buffer. For one, I am going to search and replace this with just fused, so that I don't have to keep typing that out over and over and over again, because that actually isn't as funny as I thought it was 10 minutes ago. This is going to be a struct. Yeah, let's leave that as undefined now. This is going to be a struct containing two things. It's going to contain the vertex buffer and the regular buffer, the source buffer. To get the source buffer, let's create a struct out of this. Let's create a struct. So it's going to have the vertex buffer. That needs to be a comma, raw, or a source, or whatever you want to call it. I'm going to call it raw because I call it that in a few other places. That's just going to be a buffer containing the raw vertex data. Buffer create from vertex buffer. Like that. There is also going to be the matter of if you already have a fused, some fused level data, you will want to get rid of that. This actually was something I should have addressed earlier, but you will want to delete it first. Like this, vertex delete buffer like that. And then, where are some of the other places this is referenced? You know what I could do? I could put the collision information in there as well. That might make sense. All right, we'll put the collision information in there as well. And now when we save this, instead of having to go to and from the vertex buffer and all that, we can just say fused dot raw, because that's the buffer, that's what it is already. And let's see, some other locations where this is used. Fused dot collision. That is what I called it, right? I think that's what I called it. Yeah, that seems to be what I'm calling it. Down here when we load it out. Then we also don't have to delete that buffer, because we can just keep them both around in memory. Anymore. I think when I set the collision, yeah, when I draw it, for one, I need to get that. And okay. Fuse.collision. I don't know if that's been initialized yet. We'll initialize that up here at the top. I feel like the ground vertex buffer, that plane could go just into the fuse vertex buffer as well, but I want to keep it separate. Fuse can be can be that. Refactoring. Fun. Actually, you know what? Don't make that undefined. We're just gonna make this the nominal 10 by 10 grid. And then okay. Now we're back to where we started. I think that's everything. So the fused collision data, the fused everything data really is all in a single struct, so it's grouped together, which is really the point of structs. Should check that for undefined instead of the struct itself, since the struct is now always going to be there. What else was there? There's freezing the vertex buffer. Vertex freeze, like that, and also when you fuse map entities. Okay. Vertex and vertex free should be down here. Like that. Frez. All right, spelling the word freeze correctly. And I think now we should have a frozen vertex buffer, so this should be even faster to draw. Probably not by a staggering amount, I say, as we're now up to quadruple digits in terms of FPS real, but it's an improvement nonetheless. All right, this is definitely where I want to end it off. I don't think this is going to make a difference to the performance on the Raspberry Pi, because, again, the GPU is still doing the same amount of work, even if the CPU is spending slightly less time sending the data to the GPU. But here we have it. All right, I still kind of can. It feels like the collision is in slightly the wrong place. I should look into this. I should look into exactly where the collision information is. There's a debug collision display one of these function keys, isn't there? Yeah, okay, there's... I can't build it there. Oh, you know what? This F11 button, this is only showing... This is only showing one of the collision grids. It's not showing the one that was loaded from the file. Well, we'll worry about that some other day. There will be other polish videos. Last commit for the day. This video is admittedly not as fun as I thought it was going to be. I'm going to mark a 0.39 commit here, but it was fairly important. There will be other important things that I'll be doing next week when it comes to optimization. Let me create tag 0.39. Alright, if you want the code for this, link in the GitHub repository in the video description. Boy, this recording's been going on for an hour, 20 plus minutes. This is going to be another fun one to edit. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. I try to post about 2 game dev videos a week, one of these and one tutorial. Otherwise, I hope you all found that interesting. Onto bigger and better and more exciting things next time, hopefully. And I will see you all later. Special thanks to Kiara Elizabeth, Connor, David Key, Edward Holt, Emily Koyo, Gregory, Posho, Tusk, and Zenith for supporting these videos. If you want to see your name in the credits or to hear yourself shouted out at the end here, head on over to the Patreon page in the video description to join the fun.